In 12c, our parent function, or our function, is negative 2 times the x to the 1/3, which is the cube root of x. You might want to think of it that way instead. So what I want to do is I want to come up with the parent function, which is the cube root of x, and know what that thing looks like, and then figure out what this negative 2 does to it to transform it. So first thing I'm going to do is I'm going to generate some ordered pairs that go along with the parent function. H at x is equal to the cube root of x. So once again, being very strategic with the values that you pick, what I would want to pick is something like a -8, and the cube root of -8 is a -2. I'd want to pick 1, it's a perfect cube, or -1, and the cube root of -1 is a -1. The cube root of 0 is 0, the cube root of 1 is 1, the cube root of 8 is 2. So that would be the parent function. If I graph that, I'd have the ordered pairs, and I'm going to put those on here for you. 0, 0. -1, 1, -1, -1, say it right. And this always gets me, because this is your first one. This is 1, 1. And then we have 8, 2. So that's going to be a little bit harder to envision where that is. I'll put it out here, 5, 6, 7, 8, up 2. So that's out here. And then -2, 1, 2, 3, -8, -2. So let's get a color that we can see throughout the entire graph. This is what the parent function looks like before we do any changing to the graph. Now what we're going to do to change this graph is we're going to multiply all the y values by -2. Since it's outside grouping symbols, it is a vertical transformation because it is multiplication, it is a stretch or a shrink. So now what's going to happen is all these y values are going to get multiplied by -2. So -2 times -2 is a +4. We end up with a +2, 0, -2, -4. So these are the ordered pairs that I want to graph now for my new graph. So I want to graph the ordered pair 0, 0 to start off with. Okay, it went through that last time. I want to graph the ordered pair -1, 2, -1, up 2. I want to graph the ordered pair 1, -2. So 1, -2 is down here. And then to help give me a little bit more shape, I'm going to use the -8, 4. So there's a -8 up 4. And then we also have 8, -4. So 8, -4 is down here. So my graph is looking like this. So we have this vertical stretch, a reflection across the x-axis. Now we can start answering our questions about domain, range, continuity, and increase and decrease. So the domain, there are no gaps. As I look at this graph from left to right, there are no gaps across the entire domain. So that means the domain goes from a -infinity to infinity. If you don't see any jumps, if you don't see any vertical asymptotes, the domain is all real numbers. The range is also all real numbers. It is continuous throughout its entire process through the graph, and it's going to keep going up, although gradually, forever, and it'll keep going down, although gradually, forever, so all real numbers. Continuity, we just got done saying it doesn't have any jumps or gaps, so that's through the entire interval. It's increasing. Well, this graph is always and continuously falling, so this is never, but it is decreasing on an interval from -infinity to infinity. So there was your results for 12C.